In this video, we're going to complete some applied normal problems. These are just normal probability problems applied to a particular situation. The first problem focuses on the Stanford-Binet Test, which is a test given to elementary school students. Stanford-Binet test scores are designed to be normally distributed with a mean of 100 and standard deviation of 16. Given this information, what's the probability that a randomly selected student has a Stanford-Binet score that's greater than 120? As for all problems, I advocate constructing a picture of this. The mean is 120, the scores are normally distributed. We're seeking the probability that an individual has a score greater than 120. So we're seeking the red region in this figure below. The first step in the process is to find the z-score of the score of 120. The formula for z-scores is the score, x, minus the mean, mu, divided by the standard deviation. In this situation, we have 120, the score, minus 100, which is the mean, divided by the standard deviation, which is 1.25. In other words, a score of 120 is 1.25 standard deviations greater than the mean. Go to the normal table, find the z-score, the standard deviation score of 1.25, gives us a probability of 0.3944. Now, using this table, we know that 0.3944, or 39.44% of the scores fall between 100 and 120. But we're looking for the red region, those that are greater than 120. Here you need to use the fact that 50% of the scores are greater than the mean. So 50% of the scores are greater than 100, but 39.44 fall between 100 and 120. So 0.5 minus 0.3944, which is 10.56. So there's a 10.56% chance, or a probability of 0.1056, that a randomly selected student has a Stanford-Binet score that's greater than 120. We could also find this answer using the Rossman-Chance applet. When I open the Rossman-Chance applet, the default mean is 0 and the standard deviation is 1. So what we need to do is we need to set up the mean and the standard deviation to correspond to the situation. The mean is 100, the standard deviation is 16. Click Scale to Fit, and it constructs a curve which has a mean of 100 and standard deviation of 16. We're going to find the probability of being greater than a score. X values are our scores. We want to be greater than a score of 120. Now, what I need to do is toggle this greater than less than, so it's greater than. The score is 120. The z-score is 1.25, which we already found. That says 120 is 1.25 standard deviations bigger than the mean. The probability of being greater than a score of 120 is 10.56%. The second problem we're going to look at is slightly different than the last one. The scores, okay, for the Stanford-Binet test, with the same mean and standard deviation, what percent of all individuals have a Stanford-Binet score that falls between 90 and 130? Again, drawing a picture of this, we know that 90 is below the mean, 130 is greater than the mean. This picture doesn't need to be to scale, but what we're looking for is this red region. Again, using the Rossman-Chance applet, we want to have two scores. So the bottom score is 90. The top score is 130. The applet gives us two options below. One of the option we're looking for is the probability that you are between these two values, 70.36 or 0.7036. So 70.36% of all students, of all test takers, will fall between a score of 90 and 130. The last type of problem is a backwards normal problem. In this case, instead of giving you a score and asking for the percentage, we give the percentage and ask for the score. Again, it's easiest for this case to use the Rossman-Chance applet. For the Rossman-Chance applet, we're only looking for one score, so I'll click off the second score. We want to find the probability that an individual falls in the top 3%. Okay, to be eligible for this gifted and talented program, an individual score must be in the top 3% of all scores. So we're looking for a score so that 3% of all scores fall greater than it. Going back to the applet, so we toggle the greater than less than so it's greater than. Here, enter in the probability. 3% is 0.03. Press enter, and it gives you two things. The z-score is 1.88, and the score we're looking for is 130.1. So if an individual has a Stanford-Binet score of 130.1, then they will be in the top, so 130.1 or more, they will be in the top 3% of all Stanford-Binet scores. Their z-score, in other words, also must be greater than a z of 1.88. A score of 130.1 corresponds to a z-score of 1.88. So they need to be 1.88 standard deviations or more greater than the mean in order to qualify for this gifted and talented program.